Welcome back. As promised, in this video, we're going to spend some time working on the Hangman game. I said we, I should have said you, because this is a challenge video. Up above, there are a few things I want you to get done. The first one has to do with this word instance property. Currently, we're storing it as whatever string gets passed in. If the string cat gets passed in, we store cat. Instead, what I'd like to do is store it as an array of lowercase letters. We're going to convert them to lowercase because we don't want a case-sensitive game of Hangman. That's madness. And we're converting it to an array because we're going to be iterating over these letters quite a bit. So we're going to want to be able to take advantage of features like array for each methods, for example. Now this kind of brings us into step 2. If we're tracking the letters the person needs to guess, we also need to track the letters that have already been guessed. This is going to be another instance property that we set up, and initially, yes, it's going to be empty. It'll change as the user plays the game and guesses are actually made. Now we're not going to worry about creating a method for making guesses just yet, so we can manually change that array data to simulate what the game might look like had certain letters been guessed. This brings us into step 3. We want to create a method that gives us the word puzzle back. So if I have no guesses and the word is cat, I would expect this new method to return 3 asterisks. For every letter in the word, we're going to return asterisks for ones that have not yet been guessed. Now let's imagine I play a few rounds and I guess C, B, and T. Over here, I now see C asterisk T. C and T were guessed, so they're showing up. A has not been guessed, so that's not showing up. B was guessed, but it's not part of the word, so that also has no relevance to the string over here. It's going to be your job to work on creating that string and returning the correct result. When you're trying to figure out if a given letter in Word has been guessed, you can ignore spaces, so spaces would show up. Right here, we could call the method like getPuzzle. I would expect to see 3 asterisks in a row. If I called getPuzzle down below, though, for New Jersey, I would expect to see 3 asterisks, followed by a space, followed by 6 more for Jersey. So take as much time as you need to get this one done. There is no rush. This is not a contest. It's all about learning and doing. That means if you get stuck, don't move right on to the solution. Try to actually solve it. You can use any of the videos we've worked with previously, any of the code you wrote. You can use the internet. Google around. Try to figure out how you might get this done. The only hint I'm going to give you is that you are going to have to work with some of the array methods we've explored before. Just one to be exact. So go ahead and pause the video, knock this out and test your work. I would expect to see 3 asterisks for this. We can always change the data created in step 2 to simulate what it would look like if a letter was guessed. So I could add a C into there, then I would expect to see C with 2 asterisks for this get puzzle return value. All right, that's it. Pause the video and I'll see you in about 5 seconds. How'd you do? Hopefully you were able to get that done or at least make some progress on it. We're going to start with step 1, which is to convert Word to a lowercase set of characters, then over to an array. Right here, we'll start off with 2 lowercase. We've already used that. We know 2 lowercase returns a string, and we know that on strings we have split. We explored that in the last video. So I'm going to split on, not a space, which is what we did for setting the names. We are going to split on just an empty string. That is going to take each one, breaking it out into its own array. So that is all we had to do from step 1 using what we learned in the last video. Step 2 is to set up another instance property right here, this dot, and I am going to call this something like guessed letters. Guessed letters is going to be an array as well, although it's going to start off empty and its data will change over time as the user actually plays the game and makes guesses. For now though, we can always simulate a guess by just adding a string in like this. The next thing we're going to do, and that's step 3, is to create the method that gives us the word puzzle back. Down below, we're going to get that done by adding something onto the prototype property. That's hangman.prototype. We can call this method anything in the world we like, although getPuzzle does seem appropriate. And we're going to set this to a regular function, since we do want to access the actual letters that need to be guessed, as well as those that have been guessed. Now in here, all we're going to focus on is generating that string. Now there are a lot of different ways you could have approached the problem. I'm going to start by creating an empty string. Let puzzle equal an empty string. Then down below, I'm going to return puzzle. What's interesting though is that in the middle, we're going to add stuff onto puzzle. We're going to loop over each letter in word, seeing if it's been guessed. Then we'll put the correct thing in puzzle, depending on whether it has been guessed or not. So right here, this dot, word dot for each. We want to do something for each letter. I'm going to set up my arrow function. We can call the individual item something like a letter. And all we need to do is figure out if letter is inside of this dot guessed letters. Right here, we're going to kick things off with an if statement. We're going to have our if condition, and we're going to have an else clause tacked on to the end. So the first thing we're going to do is check if the letter is indeed in that array. So right here, if this dot guessed letters includes, I'll use includes, but you might have used something else like index of, which would have also worked. Here, we are going to go ahead and check if it includes letter from up above. Now this is going to cause this code to run for all letters that have been guessed. We also want to do something if the letter has not been guessed. If the letter has not been guessed, I'm going to set puzzle equal to puzzle plus an asterisk. Up above, if the letter has been guessed, I'm going to set puzzle equal to the current value plus the actual letter, just like this. Now we can simplify both of these further. When we're taking a string and setting it equal to itself plus something else, there's a shorthand for that. It is puzzle plus equals asterisk. This has the exact same effect as what we had before. We're going to concatenate something onto puzzle, saving it. We can do the same thing up above. Puzzle plus equals letter to tack that on. Now this isn't going to account for spaces. We can add that in by adding an or condition on here. If it is a guessed letter or letter is equal to a space. If either of these are true, we're just going to pass it through, not hiding it. Otherwise, we'll hide it. Now let's go ahead and actually test our work. It's perfectly fine if you couldn't get all the way through this one, or if you took a vastly different approach. For example, maybe you used the ternary operator in here. That would have worked just fine. If you do have a different approach and you're not sure if it's valid, just open up a question in the Q&A, post your solution, and we'll get back to you talking about any potential edge cases. Now we're going to test things out. I'm going to save the Hangman game. Over in the terminal, I'm going to run it. Node hangman.js. When I do, what do I get? I get C with 2 asterisks for cat. I get 3 asterisks followed by a space, followed by 6 for New Jersey. And this is indeed correct because the only guess that I've hard coded in is C. We could add another guess in. I could guess, for example, E. Let's add that as the second item. Then I could rerun the script. And this time around, we are getting a few letters showing up for New Jersey as well. So this is the strategy that we're going to use to actually print the current state of the puzzle. We are not accounting for someone running out of guesses. We're not allowing users to make a guess. All of that will come in time. For now, though, we do have a method for the Hangman game, and it's doing something meaningful for our little app. Now that we're done, we can remove the challenge comments up above, and that's where we're going to stop for this one. We'll be adding other methods onto Hangman to make it a fully functional game throughout this section. What I want to do in the next video, though, is jump back to talking about prototypal inheritance and how exactly it works behind the scenes. I'm excited to uncover that with you, so let's jump right in to the next one.